The ever-evolving and increasing complexity of today's battlefield means that soldiers must be more adaptable, mentally agile, and better trained than ever before. But of course, time spent training is expensive, and for a long time, the military have been looking at the best way to achieve training goals efficiently but at a lower cost. So, how can this be done? Experts believe the first step is to move away from the older chalk and talk training and provide tailored solutions to match an individual's abilities and do so in immersive environments. A wide array of methods is being made available by several companies worldwide. Two of those solutions are the use of neurological technology and immersive dismounted close combat training. The neuro-assessment technology is being made possible by a few companies, such as a joint effort from US-based companies Clay Strategic Designs and Neuro. This innovative project integrates real-time brain monitoring with adaptive teaching and assessment platforms to optimize learning. In an interview with the editor of military training, Trevor Nash, I asked him how the neuro-assessment technology works.
We all learn at different rates. Some of us find it easy, some of us don't. So one way of monitoring the stress levels of students during training is to monitor things like heart rate, brain activity, blood pressure or perspiration as sort of four examples there. And this ability to measure the brain activity in real time and then use that data to drive training decisions is quite an amazing facility. So let me give you an example of that. You and I, Naomi, are on the range and we're firing our annual personal weapons test.
Mm-hmm.
And you're quite a good shot and you are being monitored. Your heart rate is normal, perspiration is normal, brain activity is normal, and you're getting a very successful exercise being completed. I, on the other hand, terrible shot. My heart rate's up. I'm perspiring. I've got a massive issue with, my brain is all over the place and I'm not shooting very well. Now that gives the instructor a great view of why you fired well and I didn't fire well. And that can be used in assessing how further training is given. And I might be needed to give some remedial training because it may not just be the fact that I'm a bad shot. In fact, I may be a very good shot, but maybe I'm getting stressed out on the range. Maybe I had a heavy night the night before. And it's another tool to allow instructors to monitor their students so that, again, they can tailor the training that's on offer to them.
This methodology has been broadly welcomed in the US, especially by the Army Special Operations community. So can we expect a greater adoption of cognitive neuromonitoring in the future?
I would say definitely yes, because the benefit is if you're doing a training task and I'm monitoring your physiological output, and for instance, the task is quite complex, but I might see you doing the task really easily in terms of, no stressful output. I can then, as an instructor, increase the complexity of the task that I'm giving you. So I'm really stretching you, and so you will get better training. Conversely, if you're not doing too well, I can then maybe reduce the complexity of the task. So what we're trying to do is to match that training, because we never want to overwhelm somebody in training and give them so many complex tasks one after another where they can't achieve the training outcome for that particular task. So it's a great way of adding yet another thing.
As evidence continues to emerge that neuromonitoring can reduce training time, trials continue with the ultimate purpose of advancing human performance in air, space, and cyberspace. But what about neurostimulation? A study from the Wright-Patterson Air Force Base in Ohio, published in 2016, paved the way for personnel such as drone operators to sit in front of a monitor in a laboratory, wired up, and have electrical pulses sent into their brains to enhance effectiveness under stressful circumstances. This technique, known as transcranial direct current stimulation or TDCS, applied to a scalp location, wants to evaluate the efficacy of a non-invasive brain stimulation. The research stated that the brain stimulation device uses electrodes to send weak electric currents through the skull and into specific parts of the cortex. Despite some progress has been made, scientists believe that more in-depth research needs to investigate whether the improvement in performance is real and how long it lasts for. As companies race one another to improve and provide immersive training for the military, what once was an ambition with the tools made available by cutting-edge technologies has become a reality. An example is UK-based immersive dismounted close combat training specialists 4GD, developer of a series of 4 products known as Smart Facility to best equip soldiers in dismounted close combat. I spoke to James Crowley, 4GD Business Development Manager, to understand what the Smart Facility is.
So the easiest way to understand the Smart Facility is a high-tech urban training environment rather than just a shoot house or a skills house. And when we describe the Smart Facility, we break it down into 4 levels. The first level is very physical. It's a reconfigurable non-ballistic panel system that we call SimWall, and essentially allows you to have thousands or hundreds of different types of room layouts so you can train various different room clearances and various different tactics in the facility itself. The next level up, level 2, is what we call 4GAV, which is where the Smart Facility becomes intelligent. So 4GAV is essentially 3 things. It's the computer backbone to the facility that makes it smart, as I mentioned. It's a really high fidelity video monitoring system where we give a perfect top-down view of all the activity that's happening in our Smart Facility, no matter the reconfiguration of SimWall. And there's a special effects suite which interacts with all of those things. Level 3 is where we introduce smart targetry into the facility. Now, in my description of SimWall, I will have mentioned that our facilities are non-ballistic. This is for a really good reason, or in our view, for a really good reason, which is that when you train with ballistic rounds, so live rounds, often you're constrained by range danger areas. When you operate and exercise with non-ballistic rounds, you're much freer to move around as you would do in the realities of battle. So when we looked at level 3 in our smart targetry, we recognized the fact that one of the benefits of using marker rounds is that you can always put a human being on the other side of the weapon and you can engage with those guys. Level 4 is where we get to that blended reality. And that's the interplay between what 4GD do virtually and the physical facility. So level 4 is the blended part. And in short, that's the Smart Facility.
It would appear that 4GD might have tapped the vein of training potential, and the company now boasts the use of their products by elite forces on both sides of the Atlantic. I was particularly intrigued by level 2 of the Smart Facility, the 4GAV element that contains a special effect system.
In simple terms, 4GAV includes light, smoke, sound, and aroma, all of the senses really apart from touch. We don't necessarily look at the special effects as battlefield simulations. We look at them increasing immersion through background effects. What we've tended to notice in training environments around the world that we've been to is they're very much influenced by the environment they're in. Salisbury Plain is a very specific place in the UK, and it is obviously a very different temperature to, say, a village in the Middle East. It obviously smells very different, it sounds very different, and generally it feels very different. So when we look at our special effects and how we employ them as part of 4GAV, what we really try and do is work with our clients to understand the operating environment that they're going to be working in, what makes it distinct, and try and replicate exactly that inside the facility that they're working in.
For 4GD, replicating the exact operating environment in the training facility is paramount, and to do so, the company believes that there is a need to leverage the subconscious stimulants, such as adding aromas or olfactory stimulation, to the 4GAV offering. However, this element has not been widely adopted, and I was curious to understand what some of the reasons might be.
It's a good question. I mean, I think part of it is due to the fact that it is not an obvious sense to really fixate on. A lot of our aromatic experiences, if you will, tend to be very subconscious. And I think because of that, it's not really at the forefront of people's minds. I also think that to a certain extent, a lot of immersive simulation in this sense has focused on battle simulation, which tends to be explosives and does come to a certain extent with different aromas just by the fact of how those effects are delivered. I also think to a certain degree that the technology that we have now allows us to be much more sophisticated with the aromas that we deliver. And we can also deliver them at a much higher quality. I think for a number of years, it's not really been something that people have delved into, purely because it's actually quite difficult to achieve well, that really does add in a meaningful way. And I think that's probably why we haven't seen a greater uptake, is just the availability of quality and the fact that it's not really a hugely obvious sense to start working on to begin with.
It seems that there is a huge amount of progress underway, and military training is set to change in the very near future.